Hello, everyone, and welcome to today's webinar, Seed Storage, Protecting Quality from Harvest to Planting. I'm Dawn Use. I'm the editor of Spud Smart magazine, and I'm really proud to co-host this important session with the North American Potato Storage Association. This is the fourth Spud Smart NAPSO webinar, all of which you can find on the NAPSO and Spud Smart websites. Today's webinar is being recorded. If you have any questions throughout the presentation, please write them into the chat window and we'll get to them all at the end. But before we get there, I'm going to turn the mic over to Andrew Lorimer, who will read NAPSO's antitrust statement. Andrew, I'm just going to get that up on the screen for you.
We'd like to introduce the NAPSO and our antitrust statement. The antitrust laws apply to individuals just as they apply to any individual group or group of competitors. Competitors may not restrain competition among themselves with reference to the price, quality, or the marketing of their services and goods. And they may not agree or act together to restrict the competitive capabilities or opportunities of other competitors, their supplies, or their customers. Therefore, it is agreed and understood that there will be no discussions whatsoever at any meeting, whether part of structured formal meeting sessions or informally at breaks among members or otherwise, involving areas in which any of the parties compete, including pricing, product pricing policies or terms, product marketing strategies, customer territories or locations, or other competitive aspects of a company's operations. Meeting participants may have an obligation to terminate any discussion, seek counsel, or, if necessary, terminate the meeting if discussions might be construed to raise any antitrust issues. Thank you.
Thank you very much, Andrew. Okay, let's talk seed storage. We're lucky to have three really great speakers here today, and I have the honor of introducing the first, which is Leroy Salazar. He has an incredibly robust bio. I am not going to read it all, Leroy, because we will be here for the entire thing. So just to kick it off, Leroy is a fifth-generation farmer in Colorado's San Luis Valley who manages the family farm producing seed potatoes, barley, and other crops. He holds a BS and MS in agricultural engineering from Colorado State University with an emphasis in irrigation, design, and management. He served in the U.S. Army Corps of Engineers and worked as a research associate at CSU. From 1982 to 2000, he co-founded and led Agroengineering, Inc., developing water resource and irrigation programs locally and internationally. He served on numerous local and state boards and helped develop groundwater rules and sustainable water strategies for the San Luis Valley. Leroy also helped found and continues to support the Hope for Children's Foundation, has been active in Rotary, and received the L. Palmer Foundation Statewide Leadership and Service Award in 2018. Welcome, Leroy. I'm going to pass the baton to you to introduce your fellow speakers and get this presentation started.
Well, thank you very much, Dawn. You've described me somewhat. Our farm is Salazar Farms. We grow 500 acres of seed. And with me today, we have Amanda Wakasugi. Amanda is part of our partner farm, which grows 600 acres of seed. And she came to us from a larger commercial farm 8 years ago, has done an excellent job as manager of our San Nicasio seed operation. And we also have with us Bill Crowder. And Bill is a consultant with the company that I founded many years ago. He's a soil scientist, agronomist. He's been a consultant for over 30 years. He's now a co-owner of Agroengineering. And we, both San Nicasio Seed and Salazar Farms depends on Agroengineering, and Bill especially, for many of our needed consultancies in agronomy and soil science and so forth. So today I'm going to talk about some of the, first I want to start and set the stage by talking about San Luis Valley. We are high altitude, 2,300 meter in elevation growing area. Daytime temperatures in the summer are ideal for potatoes, and 80 to 85 degree daytime, 50 to 55 degree nighttime Fahrenheit. In the winter, great for storage. We are typically have a high around 40 degrees Fahrenheit and a low of around 0. So we are in an ideal place with a short growing season for growing potatoes. So we do store a lot of potatoes and ship across the country. We send seed potatoes into Washington, California, Texas, Florida, and different places. But I would just caution, the experiences we're going to talk about are our local experiences. We've been raising and storing seed for a long time, but they may not be totally applicable to all other areas. So I'm going to start out the presentation by asking Bill to start talking about some of the harvest factors affecting storage performance. So Bill, if you would, this is your first slide.
Perfect. Thank you, Leroy. Thanks for the introduction. Thanks for having me. I'm glad to be here. Let's start by talking about just the maturity of vine kill. The quality of your seed starts during the season, even prior to vine kill. When you're killing your vines, we're essentially setting the crop up for how well it's going to store. If the tubers are immature when you kill the vines, they tend to have poor skin development and higher respiration rates, which makes them more prone to shrink, to disease, and even breakdown in storage. More mature tubers generally store better because their skins are stronger and their physiology is more stable. So timing vine kill is the first big critical decision that you'll make that will impact your storage success. Ideally, the plants will be entering into senescence when you kill the vines. When the plants are still healthy, the tubers will be immature. If you over-fertilize the field, the crop, or you add late nitrogen applications, the plants will be too young and will not be entering into the senescence phase. Killing when the plants are still immature will lead to poor vine kill, thus leading to delayed skin set. It will also cost you more as you're going to have to come back in with a second application of vine kill. Now, skin set refers to how firmly the skin is attached to the tubers. A good skin set protects from water loss and from pathogens. If we harvest before the skin is fully set, we will get peeling, scuffing, essentially entry points for disease. Even small little abrasions can lead to rot later on in storage. So giving tubers enough time after vine kill for proper skin set can make a world of difference. A couple of examples from our region, we grow a couple different yellow varieties. One's a Satina and the other one's a Soraya. Both yellow varieties, like I said. The Satina will take roughly 14 to 16 days to set skin once the vines are killed. Sorayas will take twice as long, up to 28 days in many situations. So the maturity of the plant at that vine kill is one of those big decisions that can really change these requirements. It could take a 14-day skin set and turn it into a 21 or a 26-day skin set if the vines are immature. So for best seed quality, you want physically young tubers with a good seed skin set going into storage. Now, temperature at harvest really affects your bruise risk and your storage life. Cold temperatures are more brittle and bruise easily, while overly warm tubers will have higher respiration and disease risk. Ideally, we want moderate pulp temperatures to minimize damage. This means harvesting potatoes between 50 and 65 degrees Fahrenheit, which is 10 to 18 degrees Celsius. Harvest may have to be done, it will have to be done during the coolest parts of the day, which may mean if you're in a hot temperature environment, harvest occurs at night. And then towards the end of the harvest season, when temperatures are cold, you might not be able to start until mid-morning or even towards noon when those temperatures warm up. Once pulp temperatures hit 65 degrees, harvest needs to stop until there's adequate cooling. We routinely see heat rot in storage when potatoes come in too warm and the field heat cannot be taken out of the pile quick enough. At Agro, we've done extensive research on bruising rates on different varieties, and most of them will show that they start bruising once you hit about 50 degrees Fahrenheit or below, which is 10 degrees Celsius. Next up, mechanical damage is one of the most preventable problems. In addition to bruising, cuts and shatter cracks often occur during the handling and harvesting of potatoes. These injuries don't just look bad, they become entry points for pathogens and can lead to significant breakdown in storage. Gentle handling, proper equipment setup, and minimizing drops all help reduce damage and improve storage performance. We recommend drops be no more than 7 inches high at any point in the handling process. That includes the drops across the harvester, down into the truck, through all the sorting equipment and the various belts in the piler, and even the piler down onto the pile. But along with just the big drops, you have to watch the sheer number of drops, because if you have a bunch of small impacts, that can also lead to black spot bruising. We have what we call a bruise ball that we can run through equipment and the lines to determine how much damage is occurring and isolate where that damage is happening in order to address those problems. Taking time to set up your equipment is key. You need to make sure that everything is timed so all your chains are at perfect speed in relation to one another and along with the ground speed. Next up, soil moisture. Conditions can lead to harvests that matter more than what you would think. A very wet soil will increase disease pressure and make for a rougher harvest. Wet soils tend to stick together more, cling to the chains, will carry more dirt and plant residue to the storage and sorting areas. Very dry soil will lead to really hard clods that won't break up, which will damage and bruise potatoes. It will also limit how much soil will be carried up the primary chain. Ideally, you want soil to be carried up past the primary and dumping onto the secondary chain. Maintaining balanced soil moisture helps protect tubers and supports better skin set and overall quality in storage. As Leroy once taught me, we like to see about a 15% moisture deficit, or an 85% moisture, how most of the world sees it, moisture level in the soil during harvest. This means that fields might need irrigations prior to harvest. You will constantly need to monitor your moisture from vine kill to harvest. Irrigations may happen every 4 to 7 days during this period. And depending on how fast and complete the vines were killed, you may have to come back with a full irrigation even right after vine kill to get that moisture level back up to around 85%. Many of our growers will put down about a half an inch of water 1 to 2 days before digging, and then some will run real quick irrigations during the night, especially if it takes them 2 or 3 days to get across the field. That way the hills don't dry out. It helps to think of this whole process as like a chain. Decisions that each step make affect the next step. After vine kill, we want to make sure we have proper and mature skin set. We have to maintain good moisture. During harvest, we want to minimize damage. Then in storage, we can focus on curing and controlling the cooling process. The first cool down is especially important. Too fast can stress the tubers. Too slow can allow disease development. Managing each step from vine kill to cooling helps maintain quality throughout the storage. And finally, physiological age refers to how old the tuber is biologically, not just chronologically. Older tubers tend to sprout sooner and will not store as long. They will also create a higher stem count. Younger tubers often have better dormancies, but may be more sensitive to handling, especially if killed green. Field conditions, growing season stress, and maturity all influence physiological age. Seed growers will typically want an older aged seed, as this will help increase the set the following year by having more stems. This leads to smaller tubers and more of them. Most of the physiological aging occurs during the first 2 months of vine kill. The higher the soil temperatures, the more aging occurs. So the longer the tubers sit in that warm temperature, the more aging will occur. So overall, storage success really starts at harvest. By managing maturity, skin set, temperature, moisture, handling, and physiological age, we can significantly reduce losses and maintain quality throughout storage.
Well, thank you, Bill. Well, I'm going to talk about storage design, and it includes airflow, insulation, humidification, temperature controls, and things like that. And I should say that, I'm older, so I've seen a lot of phases of potato storage. When I was very young in the 50s and 60s, we still had adobe storages and below ground storages. We'd open the doors at night and vent the tops and try to do cool down that way. And then what I call phase two is when we started building metal storages and with some light insulation. We would typically have fans to blow air through the ducts, and we'd have a humidifier. And in the winter, we'd actually have to put some heat into the piles when the temperatures dropped to 0 degrees, which I can't remember what the degrees are in centigrade. But then we've come into phase three, which is, I think, our modern storages, and they all have certain things in common. They're typically metal storages with very good insulation, really good airflow. They have good cooling capacity. They have good humidification. They have good control panels, good sensors, and so they're able to keep our potatoes a lot better than we used to be able to keep them. So typically our airflows nowadays are in the range of 18 to 20 CFM, and our duct air speeds are around 1,000 CFM, 1,000 feet per minute. And this allows us for maximizing cooling capacity during wound healing and cool down. And then it allows us, by use of the VFDs, to bring the airflows down to where they're not causing this excessive shrink, but also saving us on energy and so forth. So the VFD has been a really great add-on in the last 15, 20 years to help us with better wound healing, cool down, energy efficiency, and also holding up temperatures. Okay. The other key thing that I think the modern storages have is ability to control humidification. And for us, the way we do it is each of our cellars has a humidifier, which we use significantly during wound healing and during cool down. And then we have humidicells on all of our storages. The humidicell is a really important way of cooling down our potatoes here in the San Luis Valley, because we are able to effect a 15 to 20 degree Fahrenheit cool down from what the outdoor temperatures are just through the evaporative cooling. I think that's about 10 degrees centigrade that we can drop the temperatures during the daytime. Really helps us with our ability to cool. And then the other thing here is the control of the monitoring panels, and ability to control both on-site and remotely, so that we are able to adjust temperatures as set points and all as we need to. Another thing on a panel that's nice to have is the ability to either do continuous airflow. Airflow is dependent on outdoor temperatures, indoor-outdoor temperatures, and also a forced air component that allows you to maybe run an hour or two at certain times of the days to try to keep your temperatures even in your storage. So along with the humidification and control panel, we find that we have some things that we really need to think about. When we design a storage properly, it may not be built properly. And so some of the things that we design for is insulation, trying to, with a closed cell polyurethane, spray on insulation. Our newer storages are all insulated with 4 to 6 inches, which gives us an R value of 25 to 35 R. We make sure that our plenums are large enough that we have uniform pressure inside that plenum, which allows then to have uniform pressure going into the ducts. And then, we size our humidicells, size our fans and all to provide adequate airflow. So having a good design is good, but a lot of times there's problems in the construction or as cellars get older. And so you have things like cellars underperforming for a number of reasons. And some of the reasons for underperforming cellars is that you have leaks coming into your fan room, you have leaks in the doors, in your loading doors, you have insulation that does not cover your beams, your metal beams adequately. A lot of times we'll find that when they come into insulated building, the insulation is really good between the beams, but around the beams it's not as good. So those are some of the design things that we have to think about. And the final thing is, sensors are really important. The sensors that we have in the plenum, on the return, the sensors that we have in the pile, the sensors that we have for incoming air, outdoor air, humidity, those all help us to really know if we have adequate storage conditions. And so sensor placement is really important. At our farm, we make sure that we have our company, our ventilation company, come in and calibrate all our sensors at the start of the season. So that's basically, I think, what I have to add to this conversation. And so the next part of the conversation will have to do with operational storage management, and this will be led by Amanda Wakasugi.
Thank you, Leroy. Can everyone, I hope you can all hear me. So once potato product enter our storage facilities, our primary operational focus becomes climate and respiration management. At that point, everything we do at this stage revolves around controlling air, controlling temperature, and our humidity. So we manage our harvest heat at intake. Those potatoes still carry that harvest heat. So essentially field heat accumulated during the growing and harvesting process. As we all know, if we do not remove that heat quickly, we accelerate deterioration from day one. So elevated temperatures at harvest, like Bill talked about, increased moisture loss, increased shrink, and microbial activity. So the ultimate goal is to stabilize temperature as quickly as possible to protect our quality and extend the storage life of our seed potatoes. So operationally, this means that we do prioritize that rapid cooling during harvest. Here at SAS, we do this by setting our set point 2 degrees below our return sensor after our system has been running for approximately 12 to 24 hours. And we maximize our humidity within our system at this time. We leave this temperature setting once we establish it until the entire pile has stabilized at an even temperature. The goal would be to fill a storage facility as quickly as possible to manage temperature differences so that we can effectively manage that cool down process from the beginning. When we talk about managing respiration heat, even after that initial cooling phase, the potatoes will continue to respire. So respiration naturally generates heat over time. When talking in terms of potatoes, we often see that heat not dissipating evenly. This can create localized hotspots, and those hotspots are where, of course, breakdown, spoilage, and mold typically will begin. We manage this by striving to promote optimum airflow, and again, keeping that really tight gradient of 2 degrees Fahrenheit or less from the top of our pile to the bottom of our piles. This process can take us up to 2 months post-harvest or longer, depending on the air system that we have in place. So we have several different design buildings like Leroy talked about. So each of those buildings takes us, longer or shorter depending on the design. Ultimately, our storage management is about staying ahead of temperature. If we can control heat dissipation, we can better control quality, we can better control shrink, and increase our storage longevity. On our farm, as I mentioned, we utilize what's called the step-down method, which again takes us several months, but we feel like this aids in reduced physiological aging of our seed for our customers that we ship to usually primarily in the spring months.
All right, thanks, Amanda. So at Agro, we provide a storage monitoring service where we'll go out on a weekly basis and we'll check over the storages. We take a thermal camera that will go out and we'll take pictures all along the storages looking at the pile. Like Leroy said, you can find air leaks in the system. We take pictures of the plenum, the exhaust, the doors, all that stuff, and just determine how well the storage is performing. What we do is we create a report, like you can see on the right-hand side of the screen, that relays all this information back. The pictures of the different piles in the plenum, it shows you the different temperatures within that area. And we also report back like your set point, your humidity readings, your fan speeds, how long the system's been running, stuff like that. There's a comment about, checking your supply relative humidity sensor. What we'll do is we check over sensors in the system as well to make sure that, okay, your system set point is at 50 degrees. Are you really getting 50 degrees? Is your plenum showing 50 degrees, or are you getting 52 or 53 in the plenum because the sensor's miscalibrated? So that's sort of the stuff we check while we're doing that. But part of that, one of the main concerns we end up seeing is condensation throughout the storage. Many times storage losses aren't dramatic failures. They're just like, build up over time where you get a little bit of moisture and then it just expands and expands. So condensation happens anytime warm, moist air hits a cooler surface, such as the walls or the ceilings, or like Leroy said, the beams. Sometimes the beams will be under insulated and you'll have dripping just off the beams. Or even they can show up on the potato surface themselves. And it's when that temperature drops below the dew point is when you actually get free moisture that shows up on the pile. When this happens, that's exactly what a pathogen needs to take off and start causing its damage, start breaking down the potatoes. This is very common in our area, especially this time of year when we've got such cold temperatures outside. We got a big difference between inside and outside temperatures. We see a lot of condensation starting to form. So the best practices to minimize that is to keep the air moving inside the system constantly. So if you have a variable frequency drive and you can turn that down, running the system for 24 hours a day is constantly going to keep that air moving, and you can prevent the water from falling out of the air that way. But if you're on a timed run because you don't have a VFD system or that's how you're set up, you could just simply add some fans to the top of the pile that are separate from the main system, and that way they keep running the entire time and keep that air moving. This will help prevent as much water as you can from forming on top of the pile. But beyond just, moisture on the pile, you got to watch out for the temperatures, hot spots. One of the best tools that we have for checking for hot spots is our thermal camera. So we can quickly and conveniently look over piles and see if a hot spot's starting to form or not. If at any time you see about a 1 degree difference in your pile temperature from one spot to another, and this is after the field heat has been taken out of the storage, but if you see more than that 1 degree soil temperature, that means there's something probably going on down inside that pile that you may not see on the surface, but it's starting to show up. A picture on the left you can see is a storage from this fall where we're looking at it. The scale, it is in Fahrenheit. The center point is 44.8 degrees. So you can see the little cross in the middle. That spot is 44.8 degrees. And then the scale on the right shows you that the bright, almost white, bright yellow was up at 46.2 degrees. And then the cooler areas clear down at 38 degrees. So this picture was taken middle of December when the storage was down at holding. So our set point was at 38 degrees. Most of the pile surface was at 38 to 39 degrees, but you can just see how bright that hot spot was in the storage. This is one that we caught early, but the grower was not able to move it and sort it out. So when he finally did get in there here, first part of January, they ended up throwing about half of the storage away. The longer you wait to move on hot spots, the worse it's going to get. The worst case scenario is if you didn't move this thing, you would lose the entire pile. And we see that. What happens when you have a hot spot or a wet spot in storage, you're blocking the air from going through the pile. And then it just gets worse because then you get bacteria starting in there and it starts breaking down the tubers. And the more breakdown you have, the more blockage of air you have, the less you can exhaust that heat out, the more problems you have. So the best way to deal with hot spots in your storage is, one, they make little tube fans that you can stick down into the tube and constantly blow air into the pile through a certain tube. I had another experience this last year where during piling, a grower blew out a tube and they didn't catch it in time until, the entire bin was full, and it happened to be towards the middle of the bin. So they didn't want to get in there and move half a bin just to fix the tube. So we found it with our thermal camera. It was about a 1.2 degree difference between that spot and everything else around it. So we put one of these tube fans in, blowing the air constantly through that tube, and we were able to cool it down. Where in the following week, when we showed up to do our visit, you couldn't see that hot spot anymore in the storage. So we were able to stop that situation. The other thing you can do is to put some fans on top of the pile and kind of lay them down so you're pulling air from the pile up and out. It helps a little bit, and if you catch it early enough, you might be able to help out. But otherwise, once the air stops moving through there's nothing you can physically do to force the air through there. So good storage management isn't just kind of a set it and forget it. It's actively monitoring and making small corrections before they become big problems. If you react fast enough, you can prevent the losses while they're still small. Leroy, turn it back to you.
Bill, thank you. Those of you that are seed growers that grow several different varieties will sympathize with me. On our farm, we have 19 different storage spaces, bins. We have 7 air systems that are, each one is either connected to 2 or 3 different bins or 4 different bins. We grow 16 to 20 different varieties, and we typically have had historically around 60 to 70 lots of potatoes. So how do you manage seed and storage when you have so many varieties with differing growing characteristics, different dormancies and all? Well, it's hard. It's hard because we store and we try to do things like putting similar varieties together in a field. We'll harvest similar varieties into the bins that are controlled by one air system, because the key in storage is to bring as all your varieties together in a bin as quickly as possible, and then start the healing and the cool down. And so those kinds of things tend to create a problem for us. Even though we try to do similar varieties both in the field and in storage at harvest time and so forth, but we have another issue, which is we start shipping. We harvest primarily in September, but we start shipping seed either right at harvest, or we start shipping like to California in October. And so this presents a problem because you're trying to cool down, you're cooled down, and you'd like to be shipping seed when it's 45 or 50 degrees so that they can start planting it on the other end. And so these issues present a problem. So what we try to do, if we harvest and ship at harvest, then it does become the responsibility of the receiver. And we try to give them some advice. And for example, some of them will put their seed in, and then they'll go off to other bins and then come back. And that does not create a very good situation. So we try to make sure that they would manage the seed as if it was seed. So another thing that we look at is, different varieties. The reds and yellows typically have a lighter skin at least the ones that we grow, and they're more susceptible to pressure bruising. So some of the things we do in our storages is if we have Satinas or Sorayas, we will not pile them as deep as we would, for example, a variety such as Reveilles or Norcotas. So we try to look at storage temperatures depending on variety. There are some varieties that are very low dormancy, and we try to cool them down rapidly, even if that means a 4-degree temperature difference in your pile. Because the importance on something that's has very low dormancy is to cool it down so it doesn't begin the sprouting process. Other varieties such as Reveilles and even Norcotas, we can take our time and bring that temperature down, and so we do take longer to bring those temperatures down. So those are some of the things that we consider as we put seed into storage. Now, I was asked to also, so we'll talk a little bit more about preparing seed for cutting, for shipping in a little while, but now it is Bill's and Amanda's turn to talk about seed storage protection tools and how we would manage using different kinds of strategies, how we would manage our seed storages. So, Bill and Amanda?
Thank you, Leroy. So when we talk about seed storage protection tools, preventative measures, disease suppression, and sprout control, we talk about the roles of chemical and biological tools in disease suppression when it comes to some preventative type actions. So as most of us know, with the potato storage environments, disease pressure does not just stop at harvest. Fungal and bacterial pathogens can continue to develop if temperature, moisture, and ventilation are not properly managed. So chemical and biological tools do play a supportive role in an integrative storage strategy. They are not replacements for good operational management, but they can help us provide an added layer of protection for our crop. Chemical protectants may help prevent or suppress storage disease and limit pathogen spread, while biological tools can support competitive exclusion and reduce disease establishment risk thresholds. So the key, I think, is integration. So combining your sanitation practices with temperature control, airflow management, and appropriate treatment selection to minimize that loss potential that you might face otherwise. So some of our pre and post storage practices are where integration starts for us on our farm. So preventative measures begin before our product ever enters our long-term storage facilities. So we have what we call pre-storage practices and post-storage practices. So some of our pre-storage practices include facility sanitation and removal of, past season debris or current season debris, verification of our air systems. So we do that both on farm, like Leroy was talking about. We also bring in outside contractors to go through and double check our numbers on our air system. So we kind of have a double check process there to make sure our sensors are accurate. And we do a thorough inspection of our potato storage structures, down our plenums, our whole system throughout. On our farm, for example, also prior to any major phases involving storage turnover for either a new crop or new seed incoming, we sweep out our facilities and then we conduct what we call a triple wash process for all surfaces that our seed potatoes may ever come in contact with during a storage season. And so that is comprised of that sweep out process, but then it's comprised of a thorough rinse out. So we rinse off every surface, so walls, tubes, plenums, humidicells, everything, followed by heat washing. So we have several pressure washers on our farm that we use and add heat to. And then we'll come back through after that with a sanitizing agent. So we use FS amine at a rate of 400 parts per million. So we'll go ahead and disinfect and let that sit on our surfaces. And then once that's complete, we'll then have our floors and surfaces professionally cleaned. So with our local applicator. So they'll bring in a product called Clean Pro granules. So some of these products may or may not be available to you. It would just be a matter of checking into them in your area. But it's applied with a 1 to 1,000 parts per million labeled rate. So we're specifically targeting algae, fungus, and bacteria at this point. Then once this is completed, we then follow with particle fogging. So an application of a product called Sanidate 5.0. And this is done at a 1 to 10,000 labeled rate. Again, we're just targeting spores for algae, fungus, and bacteria. So once all these processes are completed, this now deems our facility ready for potatoes. So it's kind of a lot, but we feel like by doing this before every major phase of movement, we feel like we're being as preventative as possible. And so moving into, well, sorry, hold on. I'm a little bit lost on my slides here. So with harvest and post-harvest practices, our harvest timing and handling also directly influences our storage performance. Combined with adequately timed storage applications during harvest or post-harvest. So when we enter the storage phase of the season, of course, combined with that, minimizing mechanical damage, as Bill talked about earlier, and reducing entry points for pathogens and the chance for development of any secondary or tertiary diseases that could possibly set in at that time. We also work at harvesting at appropriate maturity and moisture levels that, again, Bill talked about. Those things also lower our risk for disease from the onset, so it makes managing storage a lot simpler. So when thinking of timing of applications during harvest and post-harvest, there are several products farms turn to going into storage, such as Mertec, Fostral combos, Stadium. When I was a commercial grower, I did use Fostral. Just make sure to check your labeled rates for seed potatoes. Some of these products aren't labeled for seed. So I'm more or less talking to the commercial growers, I think, in the room. And then just double check the label for your country or state that you're growing in or shipping potatoes to. So none of these products are typically used on our farm, again, just because of our focus is mainly predominantly seed. Post-harvest, once our doors are closed for the storage season until holding, that is, we come through with a JEDAG application. So it's, again, particle fogging. The rate we go with is a 1 to 10,000 labeled rate. So we're, again, targeting algae, fungal, and bacterial spores that are, of course, rampant at this time of mass movement as we're coming into storage. So our goal is always being as preventative as possible in our management practices and keeping sanitation at the forefront of our general management practices when it comes to the seed that we hold long-term. We're a little bit different than Salazar farms, so we primarily ship most of ours into the state of Colorado or up into the Northwest. So typically their growing range or plant dates are similar to Colorado. So we do hold ours a little bit longer. So that does enable us to do that step down method patiently because we're getting them to holding and then holding them for a few months before we ship them. So products such as Sanidate 5.0 or Storax can be applied as follow-up applications as you see fit. As you're walking your storages and you think you need a little bit more coverage, you can talk to your applicator and you can apply what is recommended. But again, if you choose these products or seek similar products, the advisement is, again, to make sure you are applying by label for your specific operational goals. So moving on to seed storage protection tools in terms of sprout management. So sprout control strategies, again, must align with the intended use of the seed in question. So this can be difficult, especially if you're a grower such as ourselves or Salazar, where you have a multitude of varieties. You have crate storage or bulk storages to consider in your management plan, and sometimes those are on the same air systems. So we typically do not use any sprout suppression products or manipulate sprouting in any way on our farm. However, there are products such as 1,4-seed DMN, and I don't want to advertise for, products or companies, but I just know some of our growers use these products. So some commercial farms will use this as a prescribed program, so to speak, with generally 2 applications coming in the form of following that initial JEDAG or fogging up application right after they close their doors. They come in about a month or 2 later, so typically in November timeframe, with a shot of 1,4-seed, and then they'll come back through in February, so a few months later with that second shot to properly prepare that seed for planting. So this type of program has been shown to help create an even vigorous type sprout activity on the eyes of the seed pieces when they come to pull those out to cut and put into the ground, March, April, May timeframe. And so that's something I'm super familiar with, but I do know some of our customers practice that program. So for seed intended for planting, maintaining viability is, of course, the top priority for all of us. So that limits the range of allowable sprout suppression tools we can use to work with as seed growers. It's just imperative that any sprout suppression tools that you use, you take into consideration the varieties you're working with. So a dormant variety like Reveille, for instance, versus a Norcota, you might be working with different timing on the surface of those potatoes and the activities on those eyes. So just take into consideration your storage duration, and of course, again, check labeling requirements for your specific area. I think that's all I have.
Well, thank you, Amanda. I'm going to talk for just a short while about shipping. And as I've told you before, we ship from October 15th until May 15th, which presents some issues. So we do try to warm seed up in the spring for our growers here in the valley, and for ourselves, so that when we cut our seed, and we do cut some of our seed, some of it is planted as 1 drop. But we do try to warm up and cut our seed when it at about 45, 48 degrees. Put it back in to a bin, run some good humidity and a good air through it for a few days to make sure that we have wound healing. Some of the varieties that are really quite dormant will cut those earlier, because that really accelerates the physiological aging process, which we want to have at a certain time. You want to have the seed really waking up and moving when you put it into your ground. And so, it's hard for us when we ship. We'll sometimes pull a seed out of storage. If we're shipping to California or Texas or Kansas, we may pull it out when it's 40, 42 degrees. But we'll put in a reefer. We'll have the truckers set their reefers at 45 to 50 degrees, and then they finish warming it up when it gets to the other end and hold it long enough until it's ready for planting. Let me see. We typically ship a lot of our seed out of the valley in vented bags, such as what you see here. And so what we'll typically do is load seed into our trucks, hold it in our shop for a day or two, then load it into these bags. And by that time, it'll be at 45 degrees or so. And then our baggers can put it in there without additional bruising. And then we ship it at 45, 48 degrees until it's there. And the reconditioning happens on the other end. With our own valley growers, we conditioned as much as we can, depending on variety. We do have some varieties that, San Acacio does not use sprout inhibitors, I guess, or they don't have to slow it down. We have some varieties. If you look at the Columba and you look at a couple of these really short dormancy varieties, and especially in the crate storage, where it's harder to get really good cooling when you have crates that are stacked 14 feet high. It's harder to get good storage, good cooling throughout. So on a field generation 1, field generation 2, which are typically stored in crates, we will use the 1,4 seed or something similar to that. But we do try to think about when we're going to plant and when we cut our seed and when we need to start doing our prep for planting. And again, I think it's really different with different varieties and different situations for all of you from different areas of the country and Canada. But that's basically, let me see if there's anything else I left out. The cutting accelerates the physiological aging, so be cognizant of that. And I think we're now to where we need to answer some questions, and if anybody has them. And Don, I'll let you take it over.
Fantastic. Great presentation, the three of you. That was really interesting. We do have some questions and some comments, so I'll just kind of go through them. Just Philip from Quebec actually just said at the beginning that yellow varieties are on a major rise sales-wise in Quebec. So that was an interesting little tidbit. And Ross May says, supply RH is such an important factor. We recently upgraded all our supply RH sensor and they were very expensive, but have been a game changer for humidity and cooling air availability. And Alan Walder would like some information on the bruise ball. So I'm not sure how we get that to him, but Keith Tinsey has sent a link to Techmark's bruise ball. How can we get that information to people?
So we use it's a Martin Lichman tuber log. And I've got a website I can post or send or however you want me to do with that, the one that we use.
Okay. If you could just type that in the chat, that would be awesome, Bill.
Okay. Will do.
Okay. Mick Peck says, when you start ramping down temperatures after wound healing, what typical ramp rates would you use?
Well, that would just depend on if your pile's even from top to bottom. So we would take the temperature differentiation and then we would typically start ramping it a half a degree to maybe 0.75 of a degree a day. I don't know what you think about, Bill or Leroy.
Yeah, well, we like to ramp down at a half a degree a day on the more dormant varieties. There are on the varieties that have very low dormancy, we'll ramp those down at a degree a day. And I realize that's more than a lot of folks would recommend, but it's the only way to really keep down the sprouting.
And I think it just depends, like I said in my part of the presentation, on your particular operation, your particular goals, the varieties you're working with. Like I said, like over here at San Acacio, we're very patient with it because we can be. So we literally will take months to reach holding. And if there's a huge varying degree from the top to bottom and it's outside of that window of that 2 degree type or that range that we're looking for, we won't continue to ramp. We'll just hold it and wait till it evens out and then start ramping again.
Okay, next question. Is it more effective to physiologically age seed to increase stem and set numbers at the beginning or the end of the storage season or in the field before harvest?
So on that one, the best time is to actually do it in the fall, because you can get more degree units or aging units, however you want to say it, done before you start cooling them off. Once you cool off those potatoes, it's a lot harder to warm them back up to age the seed. You never can really do it uniformly in a storage and get it warm enough to actually accumulate degree days. So it needs to be done in the fall. Most of it's going to happen in the field itself when the soil temperatures are really warm. So there are calculators out there. I think Dr. Eric Allen did a bunch of work about 10, 20 years ago, calculating and figuring out how to come up with degree units to figure out, okay, well, these varieties need X number of degree units. How do you calculate that? Soil temperature in the fall is the best time to do it. We will typically, on really dormant varieties, like we have one Canela russet that CSU developed years ago. It's a very long dormancy variety. For us to get it to grow the next year and have more than just 1 or 2 stems, we need to age it. So we'll have many of our seed storages stay at 50 degrees until the end of November or even 1st of December, and then we start bringing them down. So we calculate how many degree units they've accumulated, and then we predict what it's going to be at, ramping it down at like a half a degree a day at that point, down to holding temperatures, and then bringing it back up in the spring. We shoot for, that number is going to be about 1,200 or 1,400 degree units. So we calculate it out. And so we do it in the fall. We figure it's better that way.
Excellent. If I cut my seed, how do I store it for ideal wound healing before planting?
Well, I can tell you how we do it. And we will cut our seed and store it about 5-6 feet high in the bin if we can, and we run quite a bit of air, and we run high humidity through that pile, and that allows us to do the wound healing. So that's the real simple way to do it for us. Bill, did you have any thoughts on that?
I agree. The one caveat, the one thing you got to watch out for is you don't want free moisture to form on the cut surface. So if it's too wet, if you have water down your tubes or accumulating on the floor, you're going to have some breakdown. So you don't want that, but you want warm temperatures, 45 degrees, maybe a little bit warmer, short pile, as much air as you can.
I have just one other comment. So we ship seed to California, and typically they'll do is they'll cut it, they'll wound heal it for just a few days, and then plant it. We do have a number of growers here in the valley that cut and plant immediately. That's called fresh cut planting, right? And what they will typically do, they will make sure the moisture in the field is, near field capacity, okay? So it's nice and wet, 85% of field capacity. And so if you can plant into a good moist soil and your soil temperatures are at 50 to 55 degrees, you can actually do that wound healing in the soil, in the field. And that's the reason folks in our area can get away with fresh cutting and planting. But the seed that we ship, our customers tell us that they cut, they let it wound heal for a short period of time, sometimes as little as 3 or 4 days, but often a week or 10 days, and then plant it.
Sorry, I was having a bit of a coughing fit there. Did you have something to add, Amanda?
Well, I was just going to say, I think if you have the luxury of space, if you're able to have not so high of piles, like once you cut your seed, we try to aim 5 to 6, 5 to 6, 7 feet, 8 feet. Like, don't go over 12 feet. Like, I would recommend keeping your piles low so you get maximum airflow through those piles. And then, just like Bill said, no free moisture. You obviously want to keep humidity in the seed piece, but like Leroy said, but just be very cautious with how much moisture you're allowing into your system. Just making sure you have a seed treat, probably a good thorough seed treat application covering all surfaces of your cut seed piece would be my advisement.
Excellent. Thank you. Ross would like to know if any seed buyers have concerns when you apply any type of inhibitor to the seed. Philip just pointed out that in Quebec, these seeds could not be planted. What does that look like across?
Okay, so here in Colorado, we're allowed to put out the product that we've used on our G1s, G2s on our crate storage. We're allowed to put that on a month before we plant. Okay, I know California is. I believe they have a 60-day period that you cannot plant before. So I'm not sure what the labeling is in different states, in different countries, but I do know that I would be very, very careful and observe at least the minimums that are labeled.
Okay. Is running the fan continuously better to maintain uniformity of temperatures in the pile, or is there a downside?
I think the others will have something to say here. I like to run fans continuously, but so we run them at full capacity until we get the cool down, and then we'll try to run them at if your maximum hertz or 60 hertz, which is what we usually have, right? And we'll bring them down to 40 or 45 hertz. So the thing you have to be careful with continuous airflow is if you bring that VFD down too low, you will have that chimney effect. You don't have enough pressure going into your pipes, and so the air will come up through your pile, and you'll have sprouting in columns between the tubes. But Bill, Amanda?
I agree with you, Leroy. I mean, it saves on energy turning those fans down, and you prevent the fluctuation of temperatures on top of the pile. If you turn it on and off, the top of the pile is going to warm and cool, and you're going to just promote sprouting. So running a continuous air throughout the system is better, as long as you're not getting that chimney effect like Leroy talked about.
And on some of the older systems, you might have to use a forced air to circulate it a couple times during the day.
Right.
Yeah, and we'll run ours on continuous throughout the year, just ramping down the settings, of course.
Okay, just a reminder that this is being recorded. There will be a link to the webinar in the coming days, probably not till Monday at this point. It's a Friday, but and a newsletter will go out, as well as an article will be published on the NAPSO and Spud Smart sites. I think I've come to the end of the questions. If I missed anything, let me know.
Well, thank you all.
Thank you very much to our speakers and to NAPSO for co-sponsoring.
Well, thank you, everybody.
Thank you. Thanks for having us.